Yeah, all right. So as I just said, but you couldn't hear, if you were watching this from the wide internet, I've been using Sage since I started having to teach a number theory course, and I got hooked and kept on doing it at the small university near Boston that I work at. So it's exciting to be here in Chennai, not just because of the Ramanujan connections, which of course everybody who loves number theory likes, but also because it's my first time in India, so I'm very pleased to be here, and thank you to Amri Prasad for inviting me. So let's get down to business. We have this worksheet. You can see it up on the screen, those who are local. It's also connected to the Sage Days 60. I hope that most of you will be here next week. We'll be able to interact with a whole bunch of people who will be learning about Sage and developing Sage from around India and the world. And this is based on a tutorial that I used with university professors in the United States who didn't know anything about computer systems to teach them. And so I have to acknowledge the funding that I got from the National Science Foundation, along with a couple other people that helped write a version of this tutorial. So let's talk about what Sage is. So Sage is math software. It's not just math software, it's open source math software. So it's freely available, and you can never make it something that you can take behind a paywall. It's comprehensive open source math software. So it's not just for number theory, it's not just for algebra, it's not just for numerical computations, it's for anything that you want to do with it. You can manipulate, you can do symbolics, you can do modeling, you can do visualization. Again, many of you are in pure mathematics, so you may not use all of those things. Whatever you want to do in mathematics, you can do this with Sage. And that's the goal, is to be an open source software to accomplish those goals. You can see the logo here. It's based on a really widespread computer language called Python. We won't talk about that more today. You will see a lot more about it later in the course. And so that means it's both powerful and easy to use. So if you're a beginner, like I was 8 years ago now, I think, you can still learn how to use it very effectively because of that. We'll use it in just a second. But I wanted to show you several interfaces. What I'm actually doing in front of you is not a PowerPoint or some kind of slideshow. It is itself Sage running in one of the interfaces called the Notebook. But there are some other ways that you can use it, and I wanted to show you a couple of them. So the first one is called the Sage Cell Server. If you want to do a one-time computation, and you don't want to start anything, you don't want to log into anything, and you don't want to start something on your computer, then you can use this. So let's compute how many partitions the number 9 has. The number 9 is a number you're all familiar with. If you don't know what a partition is, it's just a way to rewrite a number as a sum of other positive integers. And since this is going all the way to Seattle, Washington, I sometimes have to give it a little help. So there's 30 partitions. And that's divisible by 5, which is the theorem of Ramanujan. So that's a nice way to start things off, I hope. We can also list all of them just to make sure there are 30. I don't know if you guys are going to want to do that, and I think I might help it along a little bit here. So anybody want to count that there's 30? See, 8 plus 1, 7 plus 2, 4 plus 1 plus 1 plus 1 plus 1 plus 1. They all add up to 9. Raise your hand if you have never seen a partition before. Good, okay. So you all know what this is. Anyway, it's fun because I just had to do it once. And if I want to do it for a different one, I just change the number, I click Evaluate, and now it lists all the partitions for 10. Okay? So once-off computation. The URL is sagecell.sagemath.org. And then you can type in whatever you want. 2 plus 2 is 4. Good. Yeah, well, it is going to Seattle and back, so. OK. So it's kind of fun to do this. Welcome to those who are joining us, both live and online. Also, you can do plots. I can click on this one, and we'll see if it comes up. There's lots of things you can do. But for those of you who have a mobile device, there are Sage apps for Android and iOS. And so if you use them, it's using this functionality. Okay? I don't personally own a cell phone at all, so.
Do they work on the cloud? Or?
No, it uses the Sage Cell Server. So you download the app, and it uses this functionality I've just been using to do these.
use up space on your mobile.
Right. No, it's all done in the cloud. That's right. Yeah. No, you're not down. You can compile Sage on certain mobile devices. It takes days, but it is possible. I don't recommend it. Whoops. Get rid of that. Oh, here we go. So here's some plot of some familiar functions. Okay. So it's good stuff. All right. So another cloud option is called the Sage Math Cloud. This is a little bit more intense, and I'm not going to demo it very much. It does require a little more bandwidth, I think, but it has a lot more power. You essentially get as many Linux file systems as you want in the cloud with the Sage Math Cloud. So let's take a look at this demo, which is very, very short that I made. 2 plus 2, if I press Shift and Enter, it gives me 4. And so now it's going to tell me the answer is 4. And it, again, went out in the cloud. I can do some annotation. You can do a lot of stuff. And the point is that inside of the project, I can get more files. And so if I wanted to make a LaTeX file, if I wanted to collaborate with somebody on a paper I was writing, or if I wanted to do some command line stuff, or all kinds of stuff, I press the plus new IPython notebook, file, LaTeX document. There's so task list. I don't use this, but a lot of people do, and they really, really, really like it. So if you're interested in this, cloud.sagemath.com is a place to go.
Great for writing collaborative papers.
Yes, absolutely. The goal is to be able to be multiply collaborative. They use it for some classroom contexts. I just haven't happened to be using it because the way that I use it doesn't need this. But for a lot of people, this is something that they really like. And if you want more computational resources or more file space, the person who is in charge of this will gladly sell you that. But it's free for most ordinary purposes. So anyway, that's a fun thing to know about.
Did we say something about the person who runs?
Yes, I can say that the name of the person is William Stein, who's the organizer and the founder of Sage. He basically he realized that if he wanted his students to be able to use computational software after they graduated and not have to pay huge licensing fees, that he would just have to write his own program. So he wrote it from scratch in 2005, 2006, and it hasn't gone back since then. So yeah, William is based in Seattle, Washington, at the University of Washington. So anyway, so this is his baby right now, is the cloud. It's pretty fun. But I'm just not using it. There are some tutorials, and anything you can do on Linux, you can do there. It's just a complete Linux file system. If you want, you can download Sage to your own computer. Now watch, this is funny. I could get this in the United States. Okay, so this is actually at IIT Madras. This is the local server, and you can see there's a lot of different places that you can download it for. Most big Linux distributions, you can just download a binary. Most Mac varieties. For Windows, there's a little bit more that you have to do. It requires what's called a virtualization. So you have to use something called VirtualBox. It still works, and it's the most popular download because so many people use Windows. I'm told that here people mostly do use Linux and Mac, so it's pretty easy. You can also compile from source. I'm not going to say more about that. But most of you, if you're going to stay beyond today, particularly if you're going to be at the Sage Days next week, you'll want to download it to your own computer. It just makes things easier. So anyway, that's a lot of stuff that you can do. So that's if you're familiar with the command line, so let me do that. So what I can do then is I can start Sage in a terminal, and I can just do things like this. That's just the one I have as my default, right? Okay, so that's 1000 factorial. Anyway, whatever you want to do, but some people like the command line interface, or you can write scripts. You can do anything you want. Again, I'm not going to focus on it because we're going to go through the web, but it's just kind of fun to have available. Now, we finally have the notebook. This does require a login and some brief steps to open a worksheet like this. I'm not going to talk about this today because another tutorial that some colleagues and I wrote is so good that you don't even need me to do it for you. See, it has all the graphics of what does the login look like. Choose your favorite OpenID provider. That depends on which one you're using. And I believe that Professor Prasad is going to be setting up a notebook server for the use of this very class within hours.
If God is willing.
But that's how I'm going to show you the interface anyway. So we're going to stick with the notebook, but honestly, almost everything I do here is going to be something that will work in all the various implementations of Sage, so you shouldn't have to worry too much about that. Now, let's actually do some math, right? Everybody ready?
Yeah.
Yes? Okay. This is interactive, okay? This is US style, all right? You got to talk.
Yeah.
You got to, yeah, come on. All right, here we go. So, how do I get Sage to do some math? The way Sage does math in this interface, it's very similar in others, is through these little cells. You see this little box here that's kind of extending the width of my browser? That's called an input cell or a code cell. And if I click in it, blue. Click out, click in, blue. So that means it's active. And so if I want to evaluate it, you see this big evaluate button. 2 plus 2 is 4, okay? Which is not surprising, but you already knew that. So the point is that we can get the response right away. There's also a keyboard shortcut for this. So here's a harder one, and you already see the answer below. And there's this cute little thing I can do where I show you the keyboard strokes. So I'm holding down Shift, and I'm going to press Enter at the same time. So you'll see it on that little keyboard viewer, right? All right. So what happened? It factored it. All right, great. So 2 times 19 times 53. Let's see what happens with 2011. Oh, it's prime. Oh, it's so exciting. It's exciting. Okay.
That was so 3 years ago.
I know. Well, see, yeah, that you can tell that was when I wrote it. But we'll stick with 2014 because we're modern. So the idea is that you can do whatever you want, and I can just change it on the fly, right? And that's a really powerful thing. It's not like a command line interface where I'm kind of doing it again and again. And in the cloud, you know, then I'm kind of I'm relying on those resources. But this is really nice, and that's why I like the notebook, is because if I make a mistake, I type in the wrong thing, I just go back and change it, right? And if I can share this with somebody else, then they've already got what they need to do. So if my collaborator didn't know how to use factoring in Sage, then they just follow my little tutorial that I make for them. So if you want to do more math, of course, you need more input cells. This is also easy. Watch as I move through here. You see how there's little blue bars showing up? In every interface, there's something similar to get something new going on. So I can click inside a bar, but I can also click on top of a bar, and then I get a new cell. So if you wanted to do this when you try it out later, you can try and make some. If I want to delete the cell, I'll press delete. Maybe this cell I'll do 2 plus 5. But then I decided I didn't want 2 plus 5. Delete, and it's gone. See, no cell. But I can always put another one back in. So it's really convenient. You can go back and forth. So there's lots and lots of other special keyboard strokes to do really fancy programming type things with the cells. And you'll see their utility later on, but I'm going to assume you know nothing, so I'm not going to talk about them now. If you go to the top of this worksheet, there's a help link. And you click on that, you search for key and mouse bindings, and you'll see some of those productivity things. All right, we still haven't really done the math. I guess we did the partitions. So nonetheless, I'm going to start slow because I want to start with something everybody understands, including those of you out in the internet world. And so we're going to start with just basic symbolic functions, just to see what does Sage look like. How does this work? So this is the most elementary one that I could think of, I guess, is x squared. And so we define it. The technical term for these is callable symbolic expressions, but I'm just going to call it a function. And again, I'm going to click evaluate. What happened? Nothing. Oh my gosh, did I make a mistake? Okay, well, let's see. Maybe I'll click on f of x and see if it tells me anything. Oh, it's x squared. Oh, great. Okay, so something did happen. I didn't ask it to do anything, right? I just said, make f of x be x squared. Why do you need to print anything out? right? It's just defining something. So this is just a computer thing to get used to, is that sometimes, you just say things and then they just happen. Some of you might not be familiar with this, but for exponentiation on computers, you use the caret symbol. It should be Shift 6 on US-based laptops. I don't know if it's different on other kinds of computers. Is that something everybody knows? Okay, yeah, okay, great. All right, so f of x is x squared. Also, if I want to see what it is internally, it's actually a map from x to x squared, and that's kind of important, right? It's internally represented that way. So it's not just x squared, it's a symbolic expression, you can call it. Okay, now I can evaluate it, and what I want you to see from this is depending on the kind of output or input I give, I get different answers. If I give it an integer, I get an integer. If I give it a decimal, I get a decimal. If I give it a fraction, I get a fraction. That's really key, and later on in the course, you'll be hearing about something called coercion and all kinds of really interesting things like that that kind of make sure that whatever the input is that you start with, you're going to get the most useful input coming out of that. At the Sage Days, they'll talk about that as well. Of course, I don't have to use x, so I could have g of y. That's 2 times 1. Again, you might not want to write, you might want to do this. Oh, invalid syntax. So we want to be explicit, not implicit. Python in particular likes that. It values explicit and not implicit. Also, there's some subtle bugs, like what's xy? Is it x times y? Is it a new variable called xy? Okay, so it gets kind of tricky. So it's better to be explicit with that. I had to have that beaten into me by some other Sage developers once upon a time, but now I believe them. If you use a variable all by itself, I won't evaluate this, it very wisely gives you this name error. And that's good, because what if I accidentally typed z instead of x? They're right next to each other on my keyboard. I don't want something to happen silently where it says, oh, z, great, yeah, let's do stuff with z. No, I want it to say, you didn't tell me what z is. Okay? I don't, otherwise, it could make silent errors. It could be very, very bad at other times. So does that make sense? Explicit is better than implicit. Not always, but in these cases, it makes a lot of sense. If you really want to get around it, that's the syntax that you would use. I'm not going to dwell on it. What's more important about this one is I can put cells in 2 different lines, and they both happen. Okay? I made a new variable, and then z squared happened. So you could make arbitrarily long things in one cell. I don't necessarily recommend it, but when you're first starting, you just keep typing like do this, do this, do this, and it will do all of those things. So what do we want to do? You can square pi, and it'll give you pi squared. You square 1 over e, it gives you 1 over e squared, which it writes as e to the minus 2. These are things that I think you all know what they are, but it's nice to know that Sage. It also has things like the Catalan constant and gamma, the Euler gamma, and so forth. So there's both well-known and more unfamiliar constants. If I want to have a decimal approximation, this crowd probably doesn't care as much about that, but you'd be surprised with some of the people in the number theory crowd. They want to approximate some analytic functions. You can use this capital N function. And so pi squared should be about 9.89, right? Yeah? Hello? Yeah? So another way to do it is to do f of pi and then dot. And yes?
What will that end with the big O?
So
Zero?
this looks like a big O0, and in fact it's not. It's 2 parentheses. But it's hard to see that because of the size of the projecting screen. So you're right. These are 2 parentheses, actually. Well, one of the nice things about Sage I was going to tell you is that I can change stuff like that on the fly. Better? Does that make it clearer? Now that it's n and then there's 2 parentheses? So this markup thing, which is also in the cloud, is just amazing. Because you can just do anything. You can completely annotate inside of here. And you can annotate with arbitrary LaTeX, arbitrary mathematical typesetting. So whatever you want to do, you can do it inside the notebook and then say all the explanations. So whether you're teaching or whether you're collaborating with somebody or just writing up your own notes from a class, it's really, really helpful. All right, we won't get to this programming point too much today, but I want you to see there's another way to do this. So here's f of pi, that's pi squared. And then I have this dot and then an n with a lowercase parenthesis. And because the gentleman in front said so, I'll make sure that I put those parentheses separate so you can see it's parentheses. What this does is the same thing as what we just did, but it's using what's called object-oriented notation. It's the dot syntax, as I like to call it. There's two reasons we do it. One is because we have to, because it's Python. But the second is because you have a mathematical object. You've got pi squared. And you're saying, what can I do to it? You can't do everything to pi squared. You can numerically approximate it. But you can't do some random, algebraic things. Like, it doesn't make sense to talk about the pi squared element of something, right? Does it? I don't think so. Or the partitions of pi squared. Like, these are things that make sense. And it doesn't make sense to, well, you can think of a matrix that comes from pi squared, but pi squared isn't itself a matrix. So you shouldn't really be able to take the determinant of it, should you? Probably not. And so you're distinguishing between the mathematical object and the thing that you're doing to it and any extra arguments. In this case, what if I want more digits from my approximation of pi? Now I'm going to pi. Let's say I don't want 220, I want 200. All right, there's 200 digits of pi. Okay? So if I want to go back, I can just go back to 20, and now I only get 20 digits of pi. So it's distinguishing between the object, what I'm doing to it, and what extra things I do to it. We'll talk more about that next time, but it's really powerful. Trust me. Two things you might not care about as much, but it's still kind of fun to show to your friends. You can make it elegantly typeset, a nice little square root, and you can plot things. There's lots of plotting. Yeah, some of the stuff you guys are studying can't plot, but it's nice to know that you can plot Bessel functions and things like that. And there's other people here who care about Bessel functions, even if the pure mathematicians don't, right? I hope. Okay, I want to make sure. There's a lot of documentation of this. If you're feeling bold, I encourage you to try plotting the square root function between 0 and 100 and just see what happens. Okay, believe it or not, we're not doing a lot of math, right? The reason is to get you familiar with what you can do with Sage in a context-free environment. So we have all this x squared. So what if I want to do more than that? How would I find out, rather than me telling you how to do it, how would I find out how to do it? So there's a bunch of different ways that you can get stuff figured out about Sage. If you really want to get some serious work done, you have to be able to find your own answers. It's just too much stuff to be able to kind of have one person tell you all about it. The most important thing about Sage is that it's got tons of documentation, thousands of functions, some of which one of our guests has helped write documentation for. Is there a lot of documentation, Kanapan? Yeah. No, that's right. You can't do it all at once. So there's a lot of different ways to access this documentation. There is a more standard way. There's a help link at the top right of any worksheet. And I'm going to scroll up just for a second. Don't be alarmed. But if I click help, you can see it. I get this help. And then there's various, I can click on thematic tutorials. And then it'll pop up some thematic tutorials that are organized in different ways, calculus, algebra. So you want to do a little linear programming mixed integers. You want to do some algebraic combinatorics, which many people here will be interested in. Programming, you can get help about those things. There's also a reference manual that's gigantic. And so the point is that there is this documentation. But I wanted to go specifically to some other ones.
So I like the Google document.
Yes. Yeah, you can always, of course, I didn't put that here. Yes, you can always use any search engine of your choice, Google or Bing or Yahoo or whichever one you prefer. Yes. Yeah, no, oh, that's coming. That is so coming. Oh, it's going to be awesome. All right? Kanapan here is a Sage expert, so he knows about the secret sauce that we're about to put on. But we're not there yet. You can also access it without having Sage going by going to sagemath.org. And you can see there's all kinds of different standard documentation. There's a Farsi tutorial, even all these same things that we saw are all here. And there's various other resources, some of which are more kind of tutorials for students, some of which are older, but there's a lot of really good ones. So there's just tons and tons of resources that you can use online. What I want to think about is specifically this part of it, because many of you, I hope, are interested in algebraic combinatorics type stuff, right? Because that's why you're here, maybe?
More than half this room.
Okay, good. That's enough. So, and because that's what this Sage Days next week is about, so I hope that you actually are interested in that kind of mathematics. So there's all kinds of different things, and I really encourage you, go to the Sage Math doc, go to the reference manual, so you Sage reference manual, and look at this combinatorics. There's just tons and tons of different stuff. I don't even know what a Knudsen-Tau puzzle is. I know who the people involved are, but I don't know what it is. They're good mathematicians. Integer compositions. The compositions are pretty fun stuff. Partitions. Look at all the partitions you can get. Permutations, derangements. Isn't that a great word? So the thing that I didn't know about, and this is part of your homework, is going to be to look at this and find stuff you didn't know about, is these things, De Bruijn or De Bruijn sequences. I think it's De Bruijn because it's Dutch. And so I did not know what these were. I'd never heard of them. When I was preparing the tutorial, I'm like, okay, I'm going to do this. And it turns out it's a really cool, interesting object. What it is it's a cyclic sequence. It's a sequence, and let me zoom in a little on this, that has inside of it all substrings of a certain length. And so here we are. Here we have 0 and 1 are the symbols for our alphabet. All possible sequences of 3 zeros and 1s are in this. 0, 0, 0, okay, that was easy. 0, 0, 1, that was easy. 1, 1, 1. Now, they're not all there unless where's 1, 1, 0? Does anybody see where 1, 1, 0 is? You got a loop, exactly. 1, 1, 0. So all of a sudden we have all of them in there. So a De Bruijn sequence is one where they're all in there. And it says it's the shortest. Okay, so that has to be the shortest such sequence. Perhaps there is more than one. I don't know if these are unique objects. But that's really cool. So here we go. What's an element of the De Bruijn sequences? Oops. There's one of them. And maybe I can get another one. Let's see how many of them it gives me. It always gives me the same one. All right, well, let's try length 4. Ooh, 5. Ho, ho. I'm scared. That's not too bad. Okay, that was kind of long, but it exists. Okay? So there is such a thing, and Sage is computing it for me. And I didn't know what it was until I started looking at the reference manual. That's the point, right? You can learn about whatever it is you want to know, and there's often very good mathematical documentation. Sometimes a little terse, but that's what we'll get to later on in the course when we start talking about contributing to Sage. If there's something you feel like could be better explained, or if there's a reference that's missing to your paper, it's always something that you can find a way to get into Sage. That's especially for the grown-ups, right? It's like, I'm not cited enough. So this is just really cool. And I just really love finding out about new mathematics here. And the thing that gets me excited about math is learning about new mathematics. And I just really enjoy just kind of tinkering with this. And there's stuff that I never would have studied in grad school. I didn't do this in grad school. I did algebraic geometry, right? But I learned so much about special functions and combinatorics and all kinds of algebraic stuff that it's just really cool. And so sometimes it's kind of like you can just get lost in it. Well, there's something that Kanapan mentioned that I'm going to get to in just a second. It's not just searching. That would be horrible. If the only thing you could do was just search, then you would be limited to what you already knew you probably would find. But that's bad, right? You want to be assisted in helping to find new things that you might care about. So now, I don't know how many of you care about plotting, but I just like this example for a reason that I'm going to tell you in a second. Suppose there was a kind of plot that you wanted to do. Maybe a slope field plot. So you might remember from differential equations course slope fields. Well, honestly, I don't know what command is going to do that. And I really don't want to try and do a Google search for that. It seems reasonable that the command might start with pl, because it's a plot, right? So what I'm going to do is I'm going to type in P and L, and I'm going to go back and we're going to see our little keyboard viewer again. And I'm going to press tab. So you can see I'm going to press the tab key. Wait, what just happened here? What's this stuff? Plot 3D, plot log. There it is, plot slope field. So that's the command. And see, there's some underscores. And I might not have known that otherwise. I might have thought maybe it was just plot slope field instead of plot slope field. And then what are these plotkin bounds? Huh. See, it's like going to a library. Libraries are great online, very, very efficient, very useful. But what you miss is that finding something you never knew about and then learning about it, right? That's what happens here. It's like going to the library and there's a book next to the book that you wanted that turned out to be something really cool, right? So that's tab completion. If you've used command lines in other, now it wants me to pick one, all right, but I don't want to pick one. If you've used command line in certain circumstances, you may be used to this plotting, or this tab completion. If you hadn't, tab completion is so wonderful because you don't have to type as much and you just get everything you want. Oh, and if I don't want to view, I press escape. Now, let's talk about some algebraic structures. Okay, let's get a little more intense than plotting. What if I wanted some matrices? So I'm going to type mat because that seems like matrix would start with mat. If I press tab, I do get a few things. I get matroids. Sage has matroids now. The matroid community is totally on board with Sage. It's really awesome. If you don't know what matroids are, you should. So go look at. They're the natural extension of linear independence. So to all other settings. Yeah, but most of this other stuff doesn't look too familiar, and I don't want to just make a matrix. I want to know about algebraic structures related to matrices. So I press escape. That was kind of a bummer. Let's try one. Let's just try this. Now I get some stuff. What was different? What was different? But I had mat and I had mat. What did I do differently? Yeah, that's it. That's the only, so it's case sensitive. Everybody know what case sensitive means? It means, yeah, capital letters are different. My understanding is that most Indian languages don't have uppercase versus lowercase, right? So it's annoying. So that's a good point. So the gentleman in front noticed the MATLAB command, and one of the many things Sage can do is interface with many, many, many other programs. So if you have a license for MATLAB and it's installed properly, you should be able to interface with MATLAB through Sage, and Mathematica and GAP and lots of other programs. That's right. Some of them are included inside of Sage. GAP is inside of Sage. R, which probably none of you know what it is, but you all should know what it is because it's super awesome, is also included inside of Sage. Not very good for algebraic stuff, but it's like the lingua franca for data processing. Yes, so if you have MATLAB or Mathematica, you can immediately use this.
So what's the difference between uppercase matrix and lowercase matrix?
One of them is a class, and one of them is the command. I won't get into that today. There is a difference, and we can find that out, but I'm not going to answer that question other than to say that there is a difference, and you can find out what the difference is using the next thing I'm going to talk about to help. But otherwise, I'm going to leave it as a mystery. But I can get the matrix algebras, okay? So hopefully that would be useful. Now that is kind of a parlor trick, okay? It's just saying, how do I find something? It's not yet giving me more useful information. So let's go back to something, and let's try and get a little bit more in-depth something. Let's assume that I give my expression a name. So let's say I want a diagonal matrix, and here's the command for diagonal matrix. It's diagonal underscore matrix. And then I put a list, I put things inside of brackets inside of the parentheses so it knows what it wants. So I'm going to make that, and I'm going to call it M. And again, just like with f of x equals x squared, nothing happens. Everybody say, nothing happens. Okay. But now there is M. And the way I'm going to show you M is in here is I'm going to put M, and I'm going to put a dot. Remember, the dot gives you access to things that are legal to do. And now I'm going to press tab. I'm a little scared because there's a lot of stuff you can do to a matrix. QR decomposition, anti-commutator, column space, dense, is it a dense matrix, eigenspaces, Graham-Schmidt, is it invertible? Okay, you get the picture. That's not even all of them, right? So there's a lot of things that I can do. Escape, there you go. A lot of things that I can do with this matrix. This is powerful, right? Just finding a command to make a matrix, that's cool, but I could have found that out. But to figure out all the things I can do to a matrix, this is really powerful. And those things only make sense for a matrix, right? An LU decomposition does not make sense. Does it for a polynomial? I hope not. As far as I know, it doesn't make sense. And so it shouldn't show up for a polynomial. But for a matrix, I want that. Characteristic polynomial. So let's get the characteristic polynomial. And here it is. Characteristic polynomial for M. If anybody wants to check that out, you're free to work it out on your paper. But I hope you believe me. But there was lots of other things. Here was one of the things on here that I had never heard of, but seems pretty reasonable. It's called a cyclic subspace. So I'm going to make a cyclic subspace. And there it is, vector space of degree 3 and dimension 2. So degree 3 means it's considered as a subspace of R3. Dimension 2 means it's the space has vector space dimension 2 over the rationals. Sorry, not the reals, over the rationals. And then here's a basis matrix. And they usually try to find you a nice echelon form. This has a lot of information, and it's mathematically correct, too, okay? It's not just some kind of like, well, it's about that. That's one of the problems in numerical programs, right? Everybody ever used Excel to do matrices or something like Excel? Okay, it's not a good idea, right? No. Because things, invertibility is a very tough criterion. Now, there's a question you might have about this, and this is finally going to get to the question marks that Kanapan was asking. How did I know to put this vector thing in there? All my other stuff was just like this, right? Just parentheses. Characteristic polynomial, parentheses. How did I know I was supposed to put a vector in? Because I could not put a vector in, and I would get some nasty error message. So that wasn't very helpful. I could even do the following, which I'm going to do below, but I'll just do it now. I could get rid of this completely, and then I get the very enigmatic built-in method, cyclic subspace of Sage matrix, what the? So the point is that Sage wants you to put parentheses because it wants you to tell it it's a function, right? When you do math notation, it's always f of x, right? The parentheses say something goes in here. So as mathematicians, we should really understand why you need parentheses to do something to something else. Right? Math is about maps, if we believe the category theorists. If you're a set theorist, you might not like that. But we're all category theory influenced coming out of Chicago. So how would I know to do that? Almost every documentation in Sage has lots of examples that are available from right here. And this is going to work in any of the interfaces that we've talked about. Command line, the one-off cell server, anything. All I do is put a question mark at the end of the thing. So what is a cyclic subspace? What do I do with it? I'm going to press tab. I'm not going to put the keyboard viewer up again. Believe me that I'm pressing tab. All right, here comes tab. Create a cyclic subspace for a vector, and optionally a minimal polynomial for the iterated powers. These subspaces are known as Krylov subspaces. They're spanned by the vectors v, a times v. Okay, so I need a vector to do it. So I need a square matrix, and then and a vector, and then I just keep on multiplying that vector by the matrix. And eventually, it's done. And so that's the subspace that I want, that I get. And so you can see there's the input, there's the output, and then here's lots of examples. Here they're making matrices over the rationals, but you could do it over other ones as well. Here's a more complicated example. And then they test some bizarre cases that might cause problems. For instance, if you were very naughty and instead of putting a vector in, you put the word junk. Okay, it's going to say first input should be a vector, not junk. Somebody with a sense of humor made this documentation. So I'll press escape again, and now it's gone. So that means that I had to have that vector in there. Okay? Now I had to know how to make a vector to do that, but does that make sense? Right? So you need to have some information in order to do it, but the information is there. If you ever find that the information isn't there, then what you do is you send an email to myself or one of the other developers. And sorry, I'm getting out of range of the camera. Hello, welcome back. And we find a way to make sure that documentation gets in. But many of the functions have really lots of good examples. We already talked about this stuff. You can also evaluate it, but it's better to tab because of a subtle bug. I'm not going to get into that anymore. So just tab is better than evaluation. Maybe this is something you can fix in the notebook. I don't know. So, but you can, then it's there for everyone to see. And we can try it with another function. Let's try it with vector. Vector. Oh wait, sorry, vector. Question mark. Return a vector or free module element. And yes, Sage uses the word vector for elements of free modules over arbitrary PIDs. And they aren't necessarily actual vectors. This is just the way we do it. And you can see there's lots of different input options. All entries must be part of some ring, but there's lots of different ways we can do it. And they can be over arbitrary p-adics or whatever you want. Okay, so it's pretty fun. Now, that was this, right? So questions about the question mark. The question mark is your lifeblood. It gives you lots of information. No? No question? Okay. So you'll want to try this out, right? So hopefully we'll have this Sage Notebook server on campus set up soon. And there certainly are other options for trying it out. Let me just demonstrate to you that this really does work in the Sage Shell server. Now watch this. Now it won't work, but yeah, okay, so there it is. So then this is just sagecell.sagemath.org. It'll be hard to see for those who are watching from afar, but you can see it's all there. Whee! Okay. So you really can get this documentation. And then you're not searching through some ginormous manual. Yes, I did say the word ginormous. All right. There's another thing that's more important for you all because most of you will eventually, I think, want to do more than simply use Sage as a calculator. Okay? You can do that. And for my students, undergraduates doing linear algebra, calculus, things like that, usually I end up saying, here's a way that you can use Sage to get, the determinant of a matrix or to do some calculus stuff, especially because who wants to learn partial fractions anymore? And, but if you're serious about the mathematics, you want to see how was something implemented. If there's some interesting piece of mathematics, for instance, calculating the number of partitions or computing, we were talking earlier about some Lie algebra stuff, you might want to see if you can get it to work in your case. Maybe, maybe it has all the finite simple groups of Lie type implemented, but it doesn't have the monster group or something. And you want to, how do I implement the monster group? Well, then you can try and look for the source code, the instructions to the computer itself for how to make these things. And this is exciting because you guys are at the point as graduate students and postdocs and faculty to say, I'm not just going to use Sage, I'm going to make it something that I can really do anything with. And all you need to do is 2 question marks instead of 1 question mark. This is great. You see what Sage is doing. Your collaborators see what Sage is doing. And if you find a better way to do it, you can fix it. Tab. Now, this is going to be a little long because first it's going to give you all the documentation. But notice already it looks different from the documentation. It says def cyclic subspace. It doesn't just go straight to it. It looks more computery. The reason is because it's just typesetting is pure source code. So here's all the many examples. Oh, there we go. So it's actually not particularly crazy because it's not that hard to get this cyclic subspace. And here's the heart of it. You get this polynomial, and then you get some subspaces, and that's it. You compute the subspaces using some augmented matrices. Now, to go through this is not something I'm going to be able to teach you today or indeed in 2 weeks or a year. You're going to have to find out for yourself what you care about. And then you'll learn about those pieces of Sage. So there are many pieces of Sage I'm very familiar with. There are others where I honestly have not even the foggiest notion of how they're implemented because they're not my areas of expertise. But if you've got the motivation, it's not hard to go through this, right? You can even see all these errors. If people are, this is kind of protecting against stupidity. If somebody inputs a non-square matrix, should it give you back a weird answer? No, it should give an error saying you need a square matrix. Otherwise, this doesn't make sense. Okay. So I have gotten rid of that. So that is the code. The code is awesome. That's really a large point about things, but we won't say more about the code now because I'm not assuming you know anything about programming. Up to this point, I assume you know how to type, to press tab, and to type a dot in parentheses. Question?
Can we modify the code?
I can't modify it on the fly. I can't, it's not possible within the notebook. Even in the cloud, I think there's, you have to have access to it because in principle, here it's on my computer. And so actually, if I wanted to, I could change it. I'd have to restart the worksheet, and then I could have the new code for Cyclic Subspace that evilly allowed non-square input, right, or something like that. But in principle, this could be on some computer somewhere else, such as on whatever machine Omri has available, and probably you shouldn't be allowed to mess with that one on the fly. But if you have your own installation, absolutely. That's the whole point of open source software is you can do it, right? You can break it. Does that answer your question? Yeah?
Like in MATLAB, some of the functions are hard-coded. You cannot.
Yes, that is correct. So proprietary software, except in unusual circumstances with third-party packages, you really cannot change it. If I wanted to right now, I'm not going to do it for you. It's so tempting, but I'm not going to. Next time. I could go in right now and do something evil that would, like when I put in non-square input, it would say, welcome to IMSC. I mean, seriously, I could do that right. It just would not be worth your time.
But it's also quite easy, in fact. I mean,
oh, yeah. I'm not saying it's hard.
Just that part, you just change
right.
online.
But it's hard to do right now because it would confuse those who haven't. But in principle, it's really much easier than mathematics. Yes. And I know many mathematicians who do a lot of programming now, either because that's just the job that they got or because they just like it more. They're like, programming is so much easier than math, even though programming is hard. But it's a lot easier than some crazy Kazhdan-Lustig polynomials or whatever. I don't even know what those are. I've read articles. Is that what you study? Yeah? No. The young lady in front of you. Yeah. So you guys will teach. So no, good. So you will teach me about them, right? Because I don't do Lie theory, so I don't know anything about it. I know that there exist things called semi-simple nilpotent groups and stuff like that. But I had Omri knows who I had as a teacher for that quarter where we did Lie groups. I won't mention his name, but we'll say it afterwards. And it was somebody who really should not have been teaching a first-year graduate course in anything. So unfortunately, it was kind of sad. We'll talk later. Huh? I know I am, but nobody knows who it is. So it doesn't matter. So I didn't learn any of that stuff, unfortunately.
He won't be watching.
Oh, who knows? Who says it was a he? Yeah, no, actually, there were no female faculty at Chicago at the time. All right. So, but I guess I hope that's the most controversial thing I could say today. I promise not to make any comments on modern Indian politics. So one cool thing that you can do, you might have already noticed, is I can also do more than math. I can typeset. This also works in the cloud, but I haven't used it very much, so I don't feel very, I don't know. I was able to make it work here. See how the 2 + 2 = 4 is nicely typeset? That's cool. So you can do a lot more than that. There's something called tiny MCE, and there's, again, similar things in other interfaces. And there's this awesome check. Oh, I got to change this. Well, here we go. You're going to see right now what's so awesome about this. I have a mistake here. It says there is a tech rendering engine called JS Math. That is not true. That is not what is in here anymore. The rendering engine is MathJax.
How did you,
You'll see in just a second. So I got into this. I'm making changes. And now I'm going to click on this. And it's mathjax.org, of course. And now I'm going to get out of this. And there's MathJax. And MathJax, beautiful math in all browsers, right? That's what it's supposed to be about. And I can make anything that I want inside of here. All I have to do is create what's called a text cell as opposed to a code cell. In the Sage Cloud, they're the same thing. So for those watching on the internet, there's a slight difference. But I'm just going to talk about this. And all I have to do is instead of clicking for a new cell, I'm going to press Shift, and then I'm going to click. So I'm going to press Shift. You can all see me pressing Shift, right? Click. And all of a sudden, I can do all kinds of other stuff. I love math. I love Chennai. I love Prasad. He loves, what's your favorite integral?
Gaussian?
Well, but, oh, like, wait, you mean like?
Minus infinity to plus infinity.
Oh, okay. So I'm doing, right, this is, how many, you guys all know LaTeX, I hope, right?
E to the minus x
Oh,
squared.
yeah. Ugh. And now I got to make sure I did all my, yeah, okay, there we go. Right, and there it is, just ready to go. So in order to change that, I shouldn't embarrass Professor Prasad. I should just say, someone I know, right? That's what you always say when it's like one of these things like, I have this friend who has a problem, right? You know that it's really about you, but you're just trying not to say it. Like, if there is this friend who anyway. So this is really cool. And again, in the cloud, I should just say, now that we're talking about the cloud, the way it works is it uses something called Markdown. And so you have to type %MD. I'm going to try and zoom in on that a little so you can see that. And then you can basically do the same stuff. But that's just a little bit different of an interface. And I am not that comfortable with it yet because I haven't used it. But it's the same stuff is doable. It's the same engine, MathJax, that does it. The guy who does MathJax is amazing. Great mathematician, great programmer. So you can do all kinds of other formatting. There's bold, underline, fonts, colors, centering, ordered list, unordered list. So this is all done in this. And I have complete courses that I've taught using just this. It's really amazing. And you can make up lecture notes for things. You can make up collaborative documents. It's really, really, really awesome. You can link to other websites. I guess I just showed you that when I changed it to MathJax, so I don't have to show it to you again. And this is a well-known true statement, right? For some values of true, I guess I have to define what it means to do products over all prime numbers. And you just type in some crazy LaTeX, right? Type in matrices, right? There's the matrix from earlier, right? So anything you can do in math mode, you can't do more fancy stuff, right? It's only a partial LaTeX processing engine. It's a math engine, okay? It's not just arbitrary anything. You can't write entire documents. That's not the point. If you wanted to write a document, you should write a document. Which reminds me, I should tell you about Sage Tech, but I won't tell you about that today. We talked about, oh yeah, so to edit it, I just double click. Okay? Then I can save changes. Well, we're almost out of time, but luckily, I'm almost done. You can do so much more. Sage is based on Python. That's Turing complete, so you can do anything. In particular, it has lots of very easy to access things like nicely formatted HTML and other stuff. Whatever you care about when it comes to programming, if you already have programming experience, then you can do that inside of Sage because Python is a very well-established thing. Lots of outside libraries. Do you guys know about Stack Overflow? If you don't, then if you haven't programmed, then it makes sense. But if you had even a little bit programming, there's this thing called Stack Overflow. It has zillions and zillions of questions that are about any programming thing. And yeah, so you can do whatever you want. And that's what we're going to be starting to do in the next 1, 2, 3, 4 sessions. So that hopefully after 4 more sessions, you'll be ready to program with all the other people coming in for the big Sage days, which is kind of exciting. Now, you do have homework. And I'm not sure how I'm going to get this homework to you.
Yeah, I wanted to say something about
Okay, but here, so before he says something about that, the point of the homework, at least for me, is not that I'm going to grade your homework, although maybe I should. The point is for you to do 2 things. One is to start looking at searching for stuff. Learn how to find things in Sage, whether it's using the internet, question mark, tab completion, whatever. The other one is to start trying to solve problems. Boy, it sure would be nice if I didn't have to do them all by hand, right? So everything on here, almost everything, you could do by hand in Sage. But doing a little bit of programming might help a little. So like solving a Sudoku puzzle, that's something you don't need programming to do. You just find the Sage command using it. Finding a tutorial written by one of the presenters at Sage Day 60, you don't need to. Computing the sum of all primes below n, where n equals 2 million, you might need to do a little programming for that, but maybe not much. And so trying to see where you might find information about that before we start actually doing so is a really valuable thing, right? We don't want to pretend that we're in high school anymore. We really, it's like independent, right? So learning to program, unfortunately, you could have a programming book this thick and it still wouldn't have the answer to all the questions that you want. So trying to find ways to find your own answers are really important. And then finally, I think this is just important for you to realize because you're professional mathematicians. Look up the list of programs that Sage uses internally or has interfaces to. The gentleman who left was talking about that. Have you used some? I know that some of our guests have already used GAP in the past. One of you used GAP. We talked about R. And there's many other sub-programs within Sage that are really quite useful on their own. Some more so for this crowd than others. But so maybe you can explain about the homework.
Oh,
and,
yeah, so I'll just navigate to the web page.
Yeah, I'll bring up a new browser for you. So apparently the course does have a web page.
It's still very rudimentary.
That's pretty rudimentary.
But the homework is going to, I don't know if people can hear me. So the homework is going to be on this web page
Very
later
good.
today. And whatever information you need, like Carl Dieter's office and things like that.
Sure, great.
Everything's going to be up on this web page. And hopefully before I go home this evening.
And I'll make sure that I have a, it won't look particularly nice, but at least some basic version of the lecture from today also. I'll have to think about exactly how I want to format that. There's a couple different ways we could do it. But eventually, hopefully, we'll have the actual server for you. And now that we're done, of course, we're happy to stick around. And if those of you who have laptops or have things in your office or whatnot, I think we may have some time to help with that. And apparently, I'll have office hours at some point as well, to be determined. Basically, whenever you say I'm having office hours. Yeah. Whenever he says I'm having office hours, I'll have office hours. So goodbye to the internet, and thank you guys all. It was a great audience, and next time you'll be shouting and screaming. We'll do a dance or something, Bollywood style, right? So thank you.